memory OLTP technology module, and in this video we will demonstrate how to create a database or how to alter the existing database to do the changes related to the in-memory OLTP technology so that we can create the memory optimized tables and natively compiled modules in this database. So let's move to the SQL Server Management Studio to do the necessary changes related to the in-memory OLTP technology. So this is the SQL Server Management Studio, and this is the query analyzer. And here we will create a new database in memory OLTP. If we have already the database, then we have to only do the alter the database and add this memory optimized file group. Memory optimized file group, which is necessary to create in the database for the in-memory OLTP changes. To create the memory optimized tables or the natively compiled modules, we must have to create first the memory optimized file group. So let's create the first the database. This is the usual syntax which we are using to create an traditional databases. So we have to specify the name of the databases. In this case, in memory OLTP DB is the name, and we have to mention the log file name also. So I'm going to create the database. So database is created successfully. Now I have to check the compatibility level, because to create the in-memory OLTP technology, it is recommended that the compatibility level should be 140 or above. So if I will see, because I have the SQL Server 2017, so which have the compatibility level 140. So its compatibility level is 140, so it's good. And now I have to do the modification in this database related to the in-memory OLTP technology. I have to create the memory optimized file group. Memory optimized tables can only be created into the memory optimized file group. Memory optimized file group is just only a file group, is nothing. So I have to alter this database, and I will add this memory optimized file group, and I have to mention this syntax contains memory optimized data. So it's successful. And after creating the file group, because file group is just a container, I have to create the file which will contain the memory optimized data. So this is a syntax to create a file in this memory optimized file group, and this is the file stream data, and I will create this file on this location to this file group, and the file name is in memory OLTP DB DF file. So I am going to create this file. We can create by using this visual environment also, and we can verify our file here also. It's created or not. This is in memory OLTP database which we created recently, and we can check the file and file group here. This is the file group. This is a primary file group creating by default, and this is our in-memory OLTP file group, and it's based on the file stream structure. And if we want to see the files, these are the files existing, and now this is the file group is in memory OLTP, and this is the file group contains this file, and this file is exist on this path. The recovery model of our created database should be the full recovery model, and now I will use this database which I created, and I will create the memory optimized table. This is the syntax to create a memory optimized table. I'm going to create a uh, durable tables. So to create memory optimized, we have to mention in the structure for creation this additional syntax memory optimized is equal to on, and durability is schema and data. This is the option. If we will not mention the durability, then by default is the it's schema and data. And I'm going to create the employee ID, which is the identity field, and it's I will create the index on this employee ID. For memory optimized tables, to index is must. We must have to create one index which can be a non-clustered or hash index. So I'm going to create here non-clustered with hash index, and for this hash index we have to must mention the bucket count. Bucket count is the should be the twice of the distinct values in these columns. So I will create a 10,000 values in this column, which will be the distinct. So I for the bucket count should be the twice of the value. So I'm going to give here the 20,000. And f name and l name are the worker and date of birth, and this is the syntax. So I'm going to create the this memory optimized table. The memory optimized table successfully created, and after creation the table, I will see that the HKCKP files will be this created under this folder. We have created here the memory optimized folder, and in this folder there are the subfolders HKV2. After creating this table, there are some files related to the HKCKP will be created. So these are the physical data and delta files. We can check by the query like this. So these are the files because data and delta files are created in the pairs, and these are checkpoint files, and two other files will also be created, root and free. And if it's the SQL Server 2014, then only these two files will exist in this folder. This folder exists on the disk, and we can go and check on the disk also. This is the path which I gave while creating the file group and files, and this is the file path, and this is the file name which I gave. And in this file name there are the subfolders. This is the folder is created when I created now the table, and this table contain the HKCKP files. So now I'm going to insert the 10,000 rows in this table, in mem table, and this is the code for creating the 10,000 records. So records are going to add. So records are added, and this is the text. Now I will access this records from this table, and I have to will on the statistics input output on, and I will also include the actual execution plan, and we'll see the also I'm going to access first the full data from this memory optimized table. Now memory optimized tables we have created, and these are now in the memory. So there should not be any input output. This IO, there are no IO involved. So let's see IOs by statistics input output and time is on, and we will see is there IO for this or not. So this is the result. These are the data in this table, and these are the messages. So there is no CPU times, and there is some elapsed time is involved. No input output, no logical reads are involved because the data is in the memory, tables are in the memory, and this is the execution plan for this in-memory optimized tables. And if I will access only one records, if because we have created the hash index, on this table, and if we are going to match the exact value, then hash index is the best index for this kind of data selection. And if we have to create the range value, then for the non-cluster index is the best options. So this is the result. Only one value is returned, and there is no CPU times involved, and there is no elapsed times, and this is the execution plan, and index seek is involved in this case. So here it's showing that storage is the memory optimized. So now if I will use this begin transaction and to access the data from this table, okay, this begin transaction, now I'm going to access the data. So there is the error that the memory optimized table using the read committed isolation level. This is the default isolation level supported, but for the it is not supported for the explicit transactions. Provide a supported isolation level for the memory optimized table using a table hint. So I can use here the table hint that for this query to use the this snapshot isolation level, but for all the queries where I'm using this begin and commit transaction, I have to mention this one. The other way is to change the isolation level at the database side. So check the current isolation level. It is a read committed for our database. This is the isolation level default by default, and I'm going to change for the database the isolation level for the this memory optimized elevate to snapshot. When I will set this isolation level, then I can use the explicit transactions, and this is also for the cross containers queries also. So now if I will try to access the data from this table by using the explicit transaction, so let's see. So now the result is came. There is no error because we have changed the isolation levels. So for the memory optimized databases, to access the cross containers data from the cross containers queries, or to use this explicit transaction, we must have to use this isolation level. I can access this memory optimized table by this TSQL, which will what will be happen if I am using this TSQL. If I will go into the SQL Server architecture. So the query which is accessing the memory optimized tables, in our case, the client has generated, it will go to the protocol layers, then thus it will go to the CDM parser, optimizer, and because this is we are accessing through the traditional way, and so it will go to the interpreted TSQL executor, and then this interpreted TSQL executor will communicate with the query interoperation, which is responsible to take the data from the memory optimized table. So it will take the data from memory optimized table, and then it will return to the client. So in this case, the query interoperation will be involved because we are accessing the memory optimized table through the traditional way through the interpreted TSQL. And the second way to access this memory optimized table is by using the native compiled module. This is the native compiled stored procedure, and this is syntax. And we can write our query here in this stored procedure, and then we will execute the stored procedure, and this is the this will take the very few instructions, and so that there is very few cycles of CPU will involved, and the performance will be the maximum. So it is recommended that memory optimized table should be accessed by the native compiled store procedure. So this is accessed by using these stored procedures, and now this is the demonstration how to create a memory optimized table and how to do the changes related to the memory optimized technology in this database.